I'm Pavel. I'm our serial software engineer, founder, and CTO. So I've been doing software engineering products for the last 25 years at least, since the high school grades. So before AI became like a major trend and wave, I spent about 6 years in services in company that's well known as EPAM Systems. And before that, I was running my own private consulting in Europe. When AI came on the market, it became, to me, much more interesting to go outside of big services, big enterprises, and start experimenting with this technology to build actual products. And that's what I'm engaged with for the last 18 months. So I built multiple products, helped several startups to get on the market like as fast as possible with the challenge for me initially and by now, and like as for one industry, was to use this new technology, which is like very much general purpose, reliably, responsibly, on time, get the benefits of it while mitigating the risks. Because like for me right now, the moment is probably even greater than the chat GPT, like back several years ago, because when the ChatGPT first came out, it wasn't clear what is the benefits, how to use it, or is it like even feasible at all to apply it for actual like useful use cases? Can we get a ROI of it? Can we kind of rely on it? So now, early in 2026, we are in the era where we already learn the fundamentals, we already understand what to expect from the technology, what not. We, even more important, we learned how to apply this intelligence to agentic workflows and process. And giving AI agency gives it like really new competitive edge compared to anything before. Because if previously we were using chatbots on demand, you ask question, you get your answer, you ask question, get answer, use some Sage, some knowledge base. Great. So you can now solve task on demand. But what agentic workflows gives us is a opportunity and capability to act autonomously. So now you can delegate parts of the workflows to your AI system that equipped with agentic capabilities and get the benefits of autonomous execution. You train your team of AI agents, you get your mission straight, you equip your agents with all the right tools and capabilities, and they are like on a mission to give you results. So we'll cover some of that today. I want to show a use case and constraints where you can use OpenClaw and still have it securely and be sure that it doesn't leak anything sensitive on your site. I'll explain why it's set up this way, what is limitations. So going like a little bit in advance, today we won't give OpenClaw access to any sensitive information, like to your email, to your like contact data, to your passwords, credit cards, to your like personal details or anything. But we'll explore several use cases where it can be used securely and understand why and how to prepare it to further integration with other systems. If you look around, there have been several experiments, and I've saw some thread on Twitter, now x.com, when someone set up their OpenClaw, gave them access to $100 and said, hey, make me $1 million. And going forward, it was like really spectacular to watch how this OpenClaw signed up for different accounts, try to trade stocks, try to set up some sales funnels, and benefit from like all the general knowledge out there. But end of the day, $100 spent, nothing made, no profits. So it doesn't work like out of the box. How I like to explain it, AI amplifies the skills that you have, the talents that you have, and that mission that you bring here kind of to the human civilization. So yes, anyone can do the app, anyone can repeat it, but can they do it with the same level of attention to detail, the same level of passion and dedication? Probably not. So if you are on a mission, if you understand well what it is you're after and what it is that you want, um, I think AI can help you to build it up the way that no one else will be able to repeat reliably with the same level of dedication. Um, because at some point of time, the differentiation becomes not about what to build, but about the mission and the values that you deliver. So just give you like very, very high level example why I think so. Um, you kind of, if you look at the use cases of AI adoption in the industry, like overall, and this is like actually the perfect segue to our first slide in the presentation. Um, Actually, only 6% of the use cases proved that they have any positive ROI at all. So, like, extrapolate that to the market and the product you mentioned build. In 6% of the use cases, anyone trying to do the same can probably get some value of it and can make money. And anyone can, but do they have that in themselves? Do they have that understanding of how to build this together? And why this fails to me looks pretty clear and obvious. AI is compressed archive of all human knowledge that accumulated over the course of civilization. So everything we ever know, everything in public domain, of course, everything that ever was ever put on the internet was compressed, categorized, systematized, and packed as like one huge archive. And we can now at school we can ask this archive a question, but eventually whatever answers we'll get are just permutations of different patterns matched to your question. So you get out of this huge archive basically some random permutation of previous patterns, some of which are useful. And this is also kind of, I can remember my university maths professor who was saying this thing about all mathematical models. And his statement was, you know what? All mathematical models, extrapolation projections that we're going to build are on, all of them. None of them actually reflect the actual world. But most of them that I will teach you are useful. So in this way, whatever like products, outcomes that you can build with AI, they are useful, but they're always wrong. And there will always be kind of this space dimension where you can fit in and find a way to uh, extract positive value from deployment. If you follow, again, your passion, your excitement, if anyone shares it, they can probably match you. So it's like, for me, a game of people using this incredible technology to amplify and deliver to the world what they want and what they have. Right now, everyone has tried ChatGPTs, Claudes, like or any other solutions, copilots in their like daily workflows, and hardly anyone haven't heard about AI because all recent years it's been all around. So there are like some hard mess. This is just something that I quickly looked up online when preparing materials for this presentation. Only 6% of the use cases actually have and see some value. And this comes to like different reasons to that. And one goal that I have today is to equip you with the knowledge and understanding first why it's not so common for everyone using AI to get the benefits and to have like positive feedback and have like the return of investment on their time and benefits. And the other understand why it happens. Today, what I want to do is first dive into some fundamentals and give you some very high level basic understanding of the technology, of its limitations, of where it makes sense to use it and when it doesn't, and also how to start using it for yourself responsibly and to some limited constraint and extent. So in the second part of this day-to-day, we'll set up OpenClaw for like every one of you. So again, like repeating myself, we're not going to give it access to anything like sensitive or private, and I'll explain kind of why, but we'll explore use cases that will make it useful for you, like in your daily use cases in your daily life. So you can just ask AI, hey, make me some money. Unfortunately, it doesn't work. Maybe it will in a couple of years, but that will be a different story. So in the nutshell, also another thing that is happening, like everyone is trying to use AI extensively, and the trend in 2025 compared to the previous year is also pretty obvious. Only 70% of the projects, like across the whole industry, were abandoned since 2024, but in 2025 even more. This is pretty explainable because most of experimentation becomes really low. So it's easy to try things, it's easy to experiment, it's easy to build proof of concept, try your ideas, and eventually fail to learn something new. So from early failures gives you an opportunity to validate your ideas, to try things, understand what works, what not to prepare yourself for building something that actually works and you can operationalize it. That's also kind of another part today. We'll kind of get these fundamentals to see how you not only can experiment, but how to prepare yourself for actual like operational like playbook. So this is kind of what I was talking about. Okay. This comes from public research and papers. These are still all well-known legacy agencies and companies that thrive on consulting, analytics, and market intelligence, like Gartner's, McKinsey's, Forrester's. Okay, so what are we going to do today? So first, we'll start with building a mental model for you to understand how AI works as a technology, as general purpose technology. Then we'll run into some very basic understanding on how token economics works, what are tokens are, how they calculate it, how much do they really cost. Then we'll come up with some kind of architecture decision metrics. So, and what I would like to inspire every one of you become an architect of your AI systems a little bit to understand how to design and structure your personal kind of AI agent, your AI experience for yourself. I'll distribute after the workshops some short prompt library, just some hints or cues that incorporate some best practices, and we can work together on any of the use cases that you would like to explore to have your own prompts built. And by the end of the day, we'll have your first working autonomous agent working and some personal AI ROI worksheets to identify and create an inventory of the use cases that would work for you that you would like to use AI for. So you are a founder, entrepreneur, or an engineer, and the first thing I would like you to mentally create for yourself, define one thing that you want AI to do that it currently doesn't. You don't have to give an answer now, but please think of it or keep it in your mental model. It will help you to build that implementation in the second part of the working session today when we'll use OpenClaw to automate of some of your typical tasks. So just start thinking about it, and it's better to always have it in writing so that you can collaborate on this. And have it like somewhere on your working sheet. So going forward, so the first part, I'll start explaining very high level, no deep technical details, no prior experience, no understanding of computer science, just a very high level understanding of how artificial intelligence works, how it's different, how we think and we work, and what are the limitations, and also how the most basic concepts like actually work and conceptualize. So I'll try to focus on details that from my experience working with founders and like consulting in the AI adoption space, help companies to make better decisions and try to kind of focus on those details that actually impact decision-making process. So first of all, as I mentioned, are basically all like modern AI is built on mostly large language models. It's a subset of machine learning, like and adopt AI role. We'll not go into details of that, but in the nutshell, are contrary to the name, large language model actually inside don't have anything about language themselves. What they do and how they're different from kind of how brain operations, they tokenize text and languages into figures, numbers. So what happens, they break the input language into different tokens, and one token can be a word or it can be a part of the word. For English language, most of the cases, one token is one word. In other languages, this is different because most of the large language models' native language is English, and that's why foreign languages are typically consume more tokens. So when you use English to communicate with your LLM, they are usually more efficient because most of the internet is in English. So there's not much we can do about it like today. Maybe potential later someone will spend efforts and build LLMs intrinsically, natively are educated and trained in other languages. But as of today, if you want to communicate with LLMs most efficiently, you better use English initially and translate the outputs like for your, for example, understanding or for customer facing questions or anything else. But my recommendation is to have at least basic prompts as templates in English always. And if you need translation at any point of time, just make it the last step. Because in the end of the day, AI doesn't care what language you speak and talks, but certainly because it was trained and the corpus of data that was trained, post-trained, and evaluated is mostly English, it's better to use it. So coming back again, what is token? For English, token is usually one word. For more complex words, it can be two tokens per word, maybe in some particular more less frequent use cases, three tokens per word. And every token has a representation of particular number or figure. So please can be 3, 5, 6, 7, and lies can be 4, 8, 7, 7, 9, etc. So behind every word, there are some numeric representation. And these numbers are built into huge massive. So you encode every piece of information that you input in the sequence of numbers. So for LLM, for the machine, every text is just a sequence of numbers in particular order. And how the training usually works, you provide the sequence of number on the input. So for this sequence of input numbers, I would expect this output. And from these pairs of inputs and outputs, the training data set is built, and it's pretty huge. Thousands of like actual humans work distributed all across the globe to create these pairs of inputs and outputs. They provide text input, text output, machine encodes it into figures and numbers, and then puts like into statistical prediction calculated. So in a nutshell, LLM is a math exercise. What it does, it calculates the most probable and the most likely statistical probable answer or number of sequence of numbers to the sequence of input tokens that you provide. And that basically it is just very, very complex, huge, sophisticated calculator. So it doesn't have intrinsic understanding of the meaning, but it has internal intrinsic probability of the meaning outcome. That's why it's so, because it trained on the huge data set, it excels at recognizing patterns. So whenever your input and output tokens have some pattern variations in the huge data set, they are most likely to be repeated like in a similar manner. So why would you care about tokens? Because once you start diverging from using like subscription monthly based tool like ChatGPT or Claude, where you just pay for the monthly and you eventually hit into limits, but you don't care about the token consumption. You just have a flat fee. This kind of works to limit until you want to automate things. Once you start thinking how to build agentic systems, that's where you have to think about connecting your inference as API. API stands for Application Programming Interface. It's basically a way to call some external service with your tokens, get the predictions, and pay for the amount of tokens that you provide. And the difference in cost can be like really huge. So just in this example, if you have like 50-page contract and there are three models from Anthropic with prices as of February 2026, if you use Haiku model, you would pay 12 cents. If you use most expensive Opus, you will pay 12. And for example, if your request or your prompt becomes like big and huge, accumulates a lot of information, Opus currently charges $75 per million output tokens. And because also they also made some upgrades and potentially models get larger context window, it's not unimaginable to burn $75 in just one request if you are careless. So for example, Gemini has 3.1 has 2 million tokens window. Sonnet 4.6 already has 1 million token window, and this is going to evolve. So eventually models get larger context window, but the price is something you need to be aware of, because when you start automating things, you'll not get a flat fee. You'll be charged for your consumption on a monthly basis. That's why you need to be very conscious on what model to choose and how tokens are calculated and estimated. The cost goes down, but and I watch it very closely. But if you look at it, for example, the cost for Opus tokens output hasn't went down for at least 6 months. So, and several good reasons for that. It very much depends on the availability of the models, also the power consumption. And yes, eventually it will go down. And also, if you are cost sensitive, you can explore some cost saving approaches like hosting your own models or running it elsewhere. Uh, Still, even if you don't care about the cost eventually, say you have your own GPU infrastructure, the larger, more expensive, compute expensive models simply respond slower. So it will take more time and energy to process the same request, and often it might not make sense. So in case of token economics, right now, I would say that there were no dramatic changes in cost of token, at least from proprietary providers for at least 6 months. It's been pretty expensive. Prices sometimes go down a little bit, but not dramatic for a while. It might change anytime because in this domain, every week something goes up. New models get out in the market from China or from other competitors, and this might change. As of now, it still can go pretty costly if you don't think about your token consumption, by default. So you better watch it closely. So this is kind of the concept that I was explaining of how the general intelligence works in how the sequence of one figures gets through complex calculations and converted into sequence of another figures. And this is how AI kind of basically LLM are functioning. And this all is processed in tokens, which are basically words in English and parts of words in most of the other languages. So the price difference can be up to hundreds or even more. And one of the opportunities for you kind of to say, for example, usually what I tell kind of people who come in for advice if you see that your monthly token consumption goes above $2,000 per month, it's probably a good time to think about having your own GPU infrastructure set up for yourself. It can be your private server, it can be a neo cloud provider with GPU hosting infra or something different. Because right now, the level of intelligence that open weights models provides is pretty amazing. So it's already almost on par with commercial models. And most of these providers that are competitive are actually from China. So again, if your use case allows to use Chinese models and you really start feeling the monthly token consumption, there's like a high chance that you can save a lot by switching to Chinese model and have your own infrastructure set up and running. So the thing about context, and that's where probably want to switch here. What is context window? I'll give you a high-level idea. So context window is the amount of information that LLM can process at a time. At any single call that your system goes to AI, it puts everything in context window. And context window is usually shared between input and output, depending on the model and architecture. But the idea is that everything short term, everything kind of that you put into your request, it goes into model context window. And it's limited to a certain extent. So 200,000 tokens is like approximately 200,000 English words. It seems a lot until you start feeding your information about your life, about your business, about your customers, your daily reports. It gets filled up pretty quickly. And especially when you work with the large amount of customer database, with your users' information, with reports, it like fills out very, very fast. And also one more important thing to remember about context window, that most of the training data sets don't have the input or context at large. So usually there are like different figures, and no proprietary company discloses how long are they input request in the training data, but they typically don't extend 50,000 tokens, which means that anything that goes beyond 50,000 on average is extrapolation. It means that it's like artificially boosting, and the quality of the outputs based on your input outside of first 50,000 will very much degrade. And also another thing that you need to understand about your context window, and that's also how this knowledge can help you to build better prompts. LLM, because of the architecture, they understand better and they keep like more attention to what's in the beginning of the context window and what's in the end. That means put everything that's important for you either in the beginning of your prompt or in the end, and put everything else in the middle. Because whatever's in the middle, it's like the cold zone. It often are the attention span, and because how the architecture of LLM works, get lost, or at least get less attention that you would like it to. So don't get surprised if you kind of provide a huge contract or a huge report and AI gets some figures that are in the middle of your contract run. It's like actually how it works. Its attention span is mostly focused only on the beginning and on the end. So how to solve the challenge of your information, your knowledge, not fitting into the context window. And that's how basically RAG was implemented. So has anyone of you heard about what RAG is? Retrieval augmented generation? Probably a couple times. So it's been quite wild in the market. So RAG is a process of equipping your AI with a tool to request information from your knowledge base in the chunks that fit within your context window. So it's a process of retrieving only relevant pieces of information from your knowledge so that they can fit within your context window. They don't pollute it with extra necessary data information and get only pieces of the data that are relevant for your particular request. And this usually works with a large amount of data. And I'll just give you like very high level understanding of how RAG embeddings work, just for your like overall knowledge. But overall, the RAG architectures have become pretty sophisticated recently, and building a good RAG requires some efforts and some understanding of its fundamentals.